Episode 1, A-Check Precision Maintenance that keeps the fleet moving. Aircraft are designed to fly for tens of thousands of hours over their lifetime. But this isn't possible without constant, structured intervention. Scheduled maintenance is what makes it possible. It ensures that wear, fatigue, and environmental stress don't accumulate into failure. And among all scheduled maintenance levels, the A-Check is where it begins. Despite being the most frequent and least intrusive, the A-Check plays a critical role in aviation safety. It represents the first line of defense, a technical routine that bridges every flight with continuous airworthiness. So what exactly is an A-Check, and why is it so essential? Understanding the A-Check. The A-Check is a scheduled, line-level inspection that is performed approximately every 400 to 600 flight hours, or every 200 to 300 flight cycles, depending on the aircraft type and the airline's maintenance program. That typically means an aircraft will undergo an A-Check every few weeks to once a month, depending on utilization. Unlike heavier checks, which require days or weeks of downtime, the A-Check is designed to fit into the operational rhythm of the airline. It is often completed overnight during routine parking or during extended layovers between flights. Although the check is relatively quick, ranging from 6 to 24 hours, depending on the aircraft, it is far from superficial. A-Checks are standardized, documented procedures that involve systematic inspection and servicing of systems essential to flight readiness. They are governed by the Maintenance Planning Document, MPD, developed by the aircraft manufacturer, and customized into task cards by the airline's Approved Maintenance Program, AMP. These task cards outline exactly what should be inspected, serviced, or tested, and by whom. What happens during an A-Check? A-Checks are composed of several recurring inspections and minor servicing tasks. The specific tasks performed vary from aircraft to aircraft and also depend on the airline's maintenance philosophy. Some distribute work over multiple A-Check cycles, A1 to A6, while others combine tasks in a single visit. Regardless of configuration, the scope is deliberate, targeted enough to complete quickly, but comprehensive enough to catch early signs of deterioration. One of the primary focuses of the A-Check is the aircraft's exterior and structure. Technicians perform a detailed walk-around to visually inspect the fuselage, wings, engine nacelles, and control surfaces. They look for signs of corrosion, fluid leaks, loose fasteners, cracked fairings, or evidence of bird or lightning strikes. These inspections may appear simple, but their value lies in consistency. Identifying a single rivet that's working loose from vibration may prevent a structural issue weeks later. Another critical task is servicing aircraft systems. Hydraulic reservoirs, engine oil, oxygen bottles, and potable water systems are all checked and replenished if needed. Brake wear and tire condition are also measured. These components are subject to daily operational stress. Landing forces, heat cycles, pressure fluctuations, and early detection of leaks or degradation can prevent costly delays or even safety incidents. The A-Check also includes basic functional tests of aircraft avionics and controls. Using built-in test systems and manual procedures, technicians verify that radios, navigation systems, transponders, cockpit lighting, and flight data recorders are operating within tolerance. Interior cabin systems are checked too, including emergency lighting, oxygen masks, fire extinguishers, smoke detectors, and life vests. Passenger experience may not be directly tied to safety, but ensuring that emergency systems are functional is non-negotiable. Many A-Checks also involve inspection of logbook entries and deferred defects. If a flight crew has reported a system irregularity, or if a maintenance item has been deferred under the Minimum Equipment List, MEL, the A-Check is often the designated time to investigate and clear it. This is where the A-Check also acts as a quality gate, a moment where previous discrepancies are closed and aircraft records are reconciled. Time, teamwork, and turnaround. What makes the A-Check unique is not just its technical content, but its operational context. Unlike C or D checks, which are scheduled months in advance and supported by dedicated hangars, A-Checks are integrated into the everyday flow of flight operations. Airlines plan A-Checks with precision, Maintenance control centers coordinate with flight dispatchers to ensure that aircraft arrive at maintenance bases with enough time to complete inspections before their next assigned flight. Any delays in execution can trigger schedule disruptions across multiple aircraft rotations. The window for error is slim. Execution relies on close coordination between line maintenance teams. A lead engineer typically supervises the operation, allocating technicians across specialties: airframe, power plant, avionics, cabin. Task cards are signed off in sequence, with all findings recorded in the aircraft's digital maintenance tracking system. If a component needs to be replaced, the part must be available immediately. If a discrepancy is found, it must be evaluated, corrected, or properly deferred in compliance with aviation authority regulations. Time pressure is always present, but safety remains paramount. The aircraft is not released for flight until every required item has been signed off and certified by a licensed maintenance engineer. The strategic role of the A-check. Although light in scope, the A-check plays a strategic role in the airline's maintenance program. It's the point where preventive maintenance becomes routine. Repetitive tasks are structured and scheduled in such a way that the aircraft is always under a watchful eye. When configured effectively, the A-check allows airlines to balance aircraft utilization with early fault detection, optimizing both safety and cost efficiency. In some cases, A-checks also act as the first stage of condition-based maintenance. Airlines using advanced health monitoring systems may align A-check intervals with real-time data from sensors tracking component wear, oil condition, brake cycles, or pressure differentials. This fusion of scheduled and predictive maintenance allows for more targeted inspections and improves the decision-making process for component replacement. Why the A-check still matters. In an era of increasingly complex aircraft and advanced diagnostics, it might be tempting to overlook the value of simple routine checks, but that would be a mistake. Many of the world's most reliable fleets operate not because of high-end tools alone, but because of consistent execution of foundational practices. The A-check is one of those practices. It is the technician walking the tarmac with a flashlight, the quiet replacement of a worn-out bracket, the careful logbook review before the sun rises. These actions may not make headlines, but they keep aircraft flying safely every day. The A-check is the pulse of a healthy airline. It's fast, methodical, and, when done correctly, almost invisible. But like a heartbeat, its absence would be immediately felt. In the next episode, we'll explore the B-check, a transitional form of maintenance that's fading from many fleets, but still holds value in specific operating environments.